Introduction to 3D Printing. Hi, Joe Cerrone. Today we're going to model this tape dispenser using AutoCAD, and we're going to take the assignment from our textbook Projects for 3D Printing, Tape Dispenser, and let's take a look at this project. Essentially, it's nice. I'm always looking for tape dispensers. And so we've got the post-it note holder from the last chapter. We might as well continue to fill our desk with other items that we can use to organize. He uses a program called SketchUp for modeling it. We're going to use AutoCAD. He uses a export plugin. AutoCAD allows you to export this as a STL, a stereolithography file, and then he's using NetFab to slice it for the 3D printing, and we'll use our Dremel 3D 45 printers. 3D printing time estimated 1 hour, 0.4 millimeter layer height, and that's a low resolution setting for the printer. He's using an Up 3D printing, 3D printer. Difficulty for modeling 3 out of 5, 4 out of 5 for printing and assembly. It is a little bit more difficult with AutoCAD than with some of the other programs because it still has a lot of 2D elements, but I find I can do everything I need to do with AutoCAD and the price is right. So if we take a look at the dimensions here, essentially we've got kind of a rectangular shape, and it has the dimensions in millimeters, and the way he recommends, and I really kind of like this from a general design standpoint of how to model it, just a step-by-step approach geometrically. And so draw a rectangle and then create this cutout, and you can use offset to do that, and you'll get these dimensions from the print. So you have to relate 80 inches by 55 inches to 80 inches by 55 millimeters. And then as you start to learn how to read a drawing, this is 15 millimeters from this edge, and then 40 millimeters from this edge to here, etc. And so create the basic sketch or the basic shape, and then you can extrude it or press pull at 40 millimeters. And then to make these clearances, I'll show you how to use AutoCAD with 3D techniques like manipulating the user coordinate system to create these cutouts, and we'll also model the tape holder. So let's get started. I have the completed file here, and in D2L what you want to do is you want to download the metric template. And so if we come back here to the home page and we go to content, title blocks, we have a B-size metric title block, and you can download that and then open it. When you open it, you're going to notice that it might not see it right away because AutoCAD looks for drawing files. And so switching back over to AutoCAD, and I don't know why it doesn't stay in that path, but we'll have to go back and retrain it to find it where we downloaded it. There it is, my B-size metric title block. We don't draw the objects in paper space, we draw them in model space, and so we'll select the tab here. Paper space is an environment for printing or displaying the object on paper, and then model space is where we'll do all the work. And what you'll do is you'll start off by setting up the interface. We're going to start using for this exercise, we're going to use a 3D modeling workspace. And so I've enabled that here, and then I really am not a big fan of the grid. Don't really need it at this point. And so here's my ribbon. And I've also enabled the toolbar by going to this little arrow here. I could hide the menu bar. I could show the menu bar. And then these are toolbars that I added because I use them quite a bit. And so I added the draw toolbar, the layer toolbar, and the properties toolbar. And you can do that by going tools, toolbars, AutoCAD, and then enabling them and just docking them. Alright, and so we can go with the line command, and we can start with a line, and we can draw that. Let's change to layer object. And we'll draw that. We want that line to track, and so we want that to be horizontal. So you want to turn polar on, and there we have our tracking line, and we'll say 80. And then we'll draw another line, turn the wheel on the mouse, 55, tracking north, back this direction 80, and then close it. And then we can start to create the geometry. Now, to make this part, I already worked on the exercise, and so I'm going to kind of display that from my finished model. And what I did was I broke it down into all the steps. I moved the model way out to the side because when you engrave your name on, you need to use a 3-point UCS, and you need to be in plan view. And so I wanted it to be all by itself, not by all of my other geometry, which is here. And so if I go through and explain this, we'll go to a top view, and then we'll zoom in. So this is the 80 by 55 basic geometry. If we wanted to put a dimension on it, dimension, linear, it'll probably come out a little subsized. Yeah. So let's not. Let's just go to distance, and we'll go from a distance from here to here, and you can see that's 80, and then we can go and repeat that, and we can go from here to here, that's 55. And if we look at these offsets, these are taken from the blueprint, and so as we start to look at how to model this, this is offset 15, and then this is offset 25. So from here to here it's 15, and from here to here it's 25. I'm going to just update my dimension scale so that when I put my dimensions on, we can see them. And so under the Fit tab, when we use metric 25.4 be a conversion factor, and we'll see how that looks. Much better. And so we model it with these dimensions, or we just basically draw it. Okay, this is just a flat 2D at this point. It's what's called a sketch in your modeling softwares. And you just want to create it to the dimensions that are given in the textbook. And so that's roughly how that works out. And then you can trim out this geometry like this and place a 5 mm radius on this edge. And then what we want to do is to press pull this into a shape. And so what we would do is to grab an isometric view, and with all the geometry we can name a view and restore it. Maybe a little bit easier, but essentially what I did here was to press pull it, because when you press pull it creates a region or a boundary shape, which if you just extruded it you would get a surface. And so you want to make sure that this is a closed polyline or a region, and that's what press pull does. It runs a macro that will select all the geometry and then make a region, and then we would make that a thickness of 44 millimeters. And then what you would do once you've done that is to take the geometry and 3D rotate it. And so once we have done that, we would use the 3D rotate command. You select the geometry, you press enter, and then you specify using an O snap a base point, and read the prompt. So down here at the bottom it tells you what it wants. Pick a rotation axis, and so I'm going to pick this red band here, and then it says select the starting angle, and again you want to track it so that you see that green line, and then you want to bring it over this way until you see the green line again. Now if you make it a little bit off, it is difficult to fix because 1 degree off of perpendicularity is not good. And so if you have trouble getting it to track out like that, then use ortho, and then you can only move it in 90-degree increments. And so you can do that if you've had too much coffee. Then once we have that rotated into the correct orientation, you cannot offset a solid. And so there's a number of ways that you can extract the edges and put geometry on, but what I do is just old school. I'll go in here to my object layer, and then I'll change the properties, which is the color, and then I'll trace over the edges of the solid model. Now you can trace over the edges, and what I recommend you do is you do that in 2D wireframe so you can see it. And then what you need to do is to do the calculations to offset and create this shape here, and you want to use a 3-point UCS on that. And so over here, even before you trace over it, what I'd recommend you do is you type in UCS, and then you select 3-point, and so I'll just type in 3. I could also hit the down arrow, I believe. And it doesn't have 3 on here. I don't know why. I've always used the 3-point UCS, but I'll say 3 for 3-point. And then the first point will be the origin. And I have to take off this. That's ortho. That's making it jittery. And then it says positive X. So I go positive X, and then I'll go positive Y. And that sets up the UCS icon. And when you think about 3D drawing, what you're really doing is just manipulating the XY axis. And so now we're just drawing on the side of this. If we wanted to create this construction over here, we can look at our tape dispenser cutout, and we can say, okay, that cutout is 20 millimeters. It's 12 from each side. So I traced over the edges, and I extended them out just because I like to exaggerate it. And so once I've traced over the 2D geometry onto the solid model, I'll offset this line 12, and then I'll offset this line 12 the other way, and then this will be 20. It's just the numbers all add up that way. And then what I did was I trimmed it, and then I press pulled it. And so you don't necessarily have to trim it. Okay, I could just press pull it. And so if I go and I say press pull, and I hover right here, you can see it's acquiring it. If we do it in conceptual, I guess it just looks cooler, but it eats more processing time. So you acquire it, and then you just pull it through the geometry right there. And with press pull, when it goes into another solid, it will subtract it. And so there we go. We've got that subtracted out. And so that's what this component is for this tutorial. And then we'll come over here and we'll use that same technique where we're going to put a 3-point UCS on the top of it, and then we're going to press pull this down 1 millimeter. And so the way that would work would be, we have the geometry over here, we've already cut out this part, and then we'll put a 3-point UCS on it. So again, UCS, type the number 3, and then origin, where X and Y and Z meet, positive X direction, use an endpoint OSNAP, positive Y direction, and then the Z-axis will be perpendicular to that. And so now we're drawing in the XY plane on the top of the tape dispenser right here. And what I like to do again is I just like to trace over it and kind of exaggerate those lines. And so if I come in here with a line, and again, you want these lines to track and to be straight. And so you put on your polar. If it's 1 degree off, it's not going to be as good as if it's directly on 090. And then I can take and look at my print, and I can say, okay, how far is this in here and this one? And it's 12. He made these line up, or at least I will, as we go through and we do that. And so you need to know which view to look at in what's called an orthographic drawing, which shows you the front, the right side, and the top view. Okay, and he says this is a section because he cut it down the middle so you can see this little relief for the tape dispenser wheel. So we're going to just offset this 12, 12. So I can come over here and I can say offset 12. I can do the same technique on the other side. Yes, I know I could go 20 the other way and just continue going, but I like to follow the blueprints as I develop my drawings. It takes time. And then I need one more on the other end because I need an enclosed boundary when I press pull something. And so that's what this is over here. I basically just traced over the top of it with the 3-point UCS, and then I'll come in here and I'll press pull that down 1 millimeter. Press pull, hover, and I'm hoping I'm acquiring just that, and I did. And we'll say 1, enter, and that will make the relief for where we'll put a little I used a hacksaw blade. I just cut it on a bandsaw, but if you have some saran wrap or aluminum foil in the kitchen, save it, save the empty box, and use the little cutter for the aluminum foil or the saran wrap, and then you can just super glue it to the top there, or you can drill a hole in the saran wrap blade and put a little screw through it. That works as well. So we go through and we create the model for the top, and then we do the same thing for the front of it. So again, it's the same technique where we can't offset the solids. What we want to do is to create a 2D geometry on this surface by going with UCS and then the number 3 for 3-point, And yes, here it is right here. You can pull it right off the menu. And if you hover long enough, you can get into the help screen. And then so we'll go here, origin, positive x-axis, positive y-axis. And it doesn't ask you for z because it's always perpendicular to the xy axis. And the direction of the z is something called the right hand rule, where if you take your right hand and hold it up on your desk and you point your index finger and your thumb, your other three fingers will point in the direction of the positive z rotation angle. And so it's more old school stuff. But we just press pull this 1 millimeter, and so the same thing. Okay, I'll come in here, press pull, and as long as we're in that XY plane, you can just hit this right like that, push it in there, 1, and that is now properly modeled. To do the cutouts, what I did was to go through and add the dimensions to the geometry here. And so if we take a look at the sketch from the textbook, he doesn't really locate it on the side here, and I think I put it 10 millimeters from the edge. And so what I did was I created the 2D geometry with this measurements. 4 millimeters is the width here, and it's also the width here. Okay, and so think of it as this 3 millimeter wheel is going to rest in this 4 millimeter slot, and so there's 1 millimeter of clearance, or half a millimeter on each side. And so that'll work so that you drop the tape holder in here and then you slide it up, because when you pull the tape off, you don't want the tape to come out, and so that there's a tendency if you put pressure on it, and so you put this little bend in it. So getting back to the drawing, the technique is basically to create the 2D shape, and then you need to put the UCS back so that you can draw it that way. And so if I say UCS, enter, I'm going to have to click in my screen, UCS, and then here's my options here, and world is the default. Think of yourself on the earth, and north is north where Alaska is, and south is where the South Pole is. And so when you start to think of coordinates in CAD, they model it on the world axes. And so when we go with world, what we're doing is we're setting up our default, which way is up. So make sure you set the axes back with the UCS command. Just say UCS, enter, and then W for world, and now you're at the default, which is what the title block opens at. And then you can go through and create this geometry, press pull it 2 millimeters, and then what I did was I 3D rotated that, because this is kind of flat on the table here where the elevation is 0. And so what I need to do is find a way to bring it to this location here on my tape dispenser. And so if you 3D rotate this by saying 3D rotate, and I'm just going to type the commands in, I can show you where they're at on the interface, but we'll select this geometry, and I want to take the line with it, because this line I can use to locate it on this surface. And so I'm going to say 3D rotate, I select the line and I select the geometry, I hit enter, and then I can just go and say, okay, put the axis here, rotate it about this red axis, starting angle, and then if I turn it till I track again, it's like that. And then I'm going to have to rotate it again with 3D rotate to get it into the right orientation. So 3D rotate, and then I grab that little handle here so that I can put that on the end, excuse me, and then I can rotate that. Looks like I grabbed the wrong axis. And if you do grab the wrong axis, then undo it and get it back. If it's, like I said, just a little bit off, it can be a problem. starting angle 90 degrees, ending angle. And then what I did was basically to take that shape and then put it on here and to subtract it. And so you can use just a regular move command. So if I come up here and I say move and I select the geometry, I can move it from this endpoint because that helps me locate it on here to there. And then I can also do the same, and it might have been better to copy it, but either way I've got a spare one over here, so I'll copy that one because you need two of them. Now copy that from that endpoint, and what you'll notice is on this side it's actually all set to go because it's ready to be subtracted. But on this side I'll have to move the geometry in, and you can just use a regular move command. I can say move, I can select it, hit enter, move it from the endpoint to the endpoint like that, and then I can create a subtraction, select the large tape dispenser, hit enter, and then select the pieces that you want to remove. That one, and it removes it. You'll notice that sometimes the sketch lines are still there. I can delete that. And then if I hold shift and I push the middle mouse wheel, I can orbit. You can also use the orbit tools over here. And then again I'm going to subtract it. And so I'm going to select the larger shape, hit enter to end the selection of the larger object, and then select the object to be subtracted from the larger object. And when you think about this subtraction process, it basically works like this. The little fish can't eat the big fish, and so if the big fish is the model and we're going to subtract a little part from it, you have to select the larger shape first, hit enter, and then subtract the piece from it like that. Alright, so again I have some sketch lines, and so this is pretty well ready to go, except for we want to kind of brand our stuff. And so what we want to do after we've got that modeled is to model the tape dispenser. And so what I did here was to just draw a circle, and the circle diameter is given on the print here. And so D24, that's diameter 24, D3, diameter 3, and then 2 is the amount that we're going to have for these little pins that come out here. And so when we come back here to this CAD geometry, this is a 24 millimeter circle, and this is a 2 millimeter. And basically all I really need to do here is to put the UCS in the right orientation, because I don't believe I can press pull it in this orientation because never mind, it seems to work. So I guess it's smart enough to know that, and so I can press pull this 2 units, or I could go this way 2 units. Let's do this. Let's go 2 units this way because it's harder to see in the complete modeling of it. And then on this one we'll go 19, and then rather than to go through and create a sketch and put that on there, I'll just take a shortcut and copy, and it allows me to copy the other cylinder because I haven't unioned it yet. So I'll copy, I'll select that shape, I'll hit enter, I'll copy it from the center here to the center here, and then I will union it. And so unioning will fuse these two parts, and you can actually see it when you go with conceptual and you union it, because you'll see like a line appear here. So if I come in here and I union this shape, this one, and don't forget the other side, I'll just do 2 right now, but you do get you can see it highlights the entire object, and then when I come here to the other side, you'll notice that this one is separate because it hasn't been unioned. So union is kind of like the beginning 3D modeling command back when AutoCAD had the advanced modeling extension in version 12. I believe it came out in 1995. I was working for College of Lake County, teaching at the vocational center. And so what we're going to do here is we're going to put our name on it, and you could put a a symbol on here or something, something like a company logo if you wanted to. The way that we do that, okay, when we do this, is that we need to have a 3-point UCS on the face of this, and so I'm going to check this in wireframe. And if I right click and I go to the quick properties, it's going to tell me it's text. And what we do is we put the text on, and you can just use regular text tools, but in order to make sure that it's on the right surface, again, UCS and then 3-point, and what we're going to do is we're going to put the XY plane on the front of the tape dispenser, and then we can go in and we can put our text. And so I can go and I can say draw text single line, and there it is, single line. And so I can say, okay, draw it right here, height 5 millimeters is fine, enter. Rotation angle 0 means it'll be horizontal, and this will see Joe Cerrone tape. Alright, now might as well just make it possessive, right? And then I can move this a little bit. Whoops. As long as I don't stop my recording, I'm okay. Move this. And like I said, as long as you're in the XY axis, this is all just like working on 2D. Now, in order to get this to be able to be engraved into the part, okay, what we have to do is we have to get a plan view. And so I'm going to copy this over to the side because I have so much geometry that we'll have all the other ones in the background. So I'm just going to bring this from here way over to here. And when I do that, I left the UCS with the other model, so I'm going to put it back on there. UCS. And if you're doing this, you don't have to because you're just working off of one model. I'm just managing step by step. So I put the 3-point UCS XY plane back on the front of it. And what you want to do is you want to say PLAN, plan, because you have to be in plan view in order to use these bonus tools. And so if I go up here to this express text and I want to explode the text, and I try to explode the text, it tells me it needs to be in plan view, or X coordinate Y Z 001. So what you need to do is you need to go and have your UCS on the front of the part with 3-point XY, and then we can type in plan, enter, enter, and then I put it over here because there's some clearance and I don't have all the other stuff behind it. Now I can go to express and I can say text and I can explode it, and I can go and explode these pieces of text, and then what it does is it turns them into geometry. And then what I can do is I can simply extrude them, and let's go with green, and we'll just make that slightly like that, and we'll say extrude. I like extrude because it's faster than press pull. If I press pull, each one of these pieces takes longer. So I'll extrude it. I'll select the objects to extrude. I'll hit enter. And then it just jumps right into the extrude command. Now we want to press it into the part because if we have a positive when we 3D print, we'll need support material because that'll be kind of hanging out into space depending on how good our 3D printer bridge is. And so I'm just going to push it into the part, and I'm going to say 1 millimeter And if I go through and verify this with a conceptual, we have two solids occupying the same space, and so we want to subtract it. So I'm going to go back to wireframe, and then I'm just going to go to subtract. I'm going to select the large shape of the tape dispenser as my base, hit enter, and then I'll select each of these letters. And I'm just trying to be careful not to get anything other than the letters here as I go through and I select them. If you do, you can hold the shift key and click on it, shift click, and it'll deselect it. And then if I click on it again while I'm not holding the shift key, it re-adds it to the selection set. You can see the selection sets add up here. And then I'll hit enter, and you could tell it kind of did something good because it took a little while for it to go and compute that. And so that's the tape dispenser. With the wheel, I modeled it in the other area. You're going to want to save it, so you can go save as, and we'll save it as our initials, project 8. I'm going to add an X to mine because I've got one already. And then you're going to want to export the STL, and so we'll go to export, other file formats, and we'll export it. It'll tell us the name, which is fine. We'll save that, select the object, hit enter, and then it'll create that file, and we'll make another video showing how to take that into the slicing software and prepare it for 3D printing. And that completes exercise project 8.